So if you've spent any time at all in the Web3 world recently, you know the biggest conversation isn't really about speed or gas costs anymore. It's all about communication, or I guess the lack of it. We're living in this really fragmented world with, walled gardens everywhere.
That's the absolute core of the problem. Our sources are showing, well over 1,000 distinct networks. You've got L1s, L2s, app chains. If Web3 is ever going to hit that next level, it needs some kind of universal transport layer, something to stitch it all together.
Okay, so that's our mission for this deep dive. We're going to get into the protocols that are trying to be that universal layer. We're focusing on one in particular, the Axelar Network. We'll look at how they're trying to solve these huge security and scalability problems, especially with all the competition out there.
And the competition is ferocious. You have Axelar, but you also have Layer Zero Labs. They were gearing up for that huge CRO airdrop in May 2024.
Yeah.
Then there's Wormhole, Hyperlane, dBridge, even Chainlink is in the game.
Yeah.
It's a real race to become the messaging layer for everything.
So let's start with the problem itself, the fundamental math problem that this whole sector is built on. Scalability. What is this geometric hurdle that everyone's trying to get over?
It all boils down to network complexity. And the model you choose at the beginning basically determines if you can grow or if you just, collapse under your own weight. A lot of the competitors like Layer Zero and Hyperlane use what's called a point-to-point model.
Okay, point-to-point. What does that mean in practice?
It means every new blockchain that wants to join has to build a direct, dedicated bridge to every other chain that's already there.
Wait, so if a new chain comes on, they don't just plug into the main network, they have to go out and individually connect to dozens of other blockchains.
To every single one. It sounds like a maintenance nightmare because, it is.
That sounds completely unscalable.
It is. Mathematically, it's brutal. If you have n chains, the number of connections you need is n times n minus 1 divided by 2. It's what we call exponential complexity.
Okay, give me a real-world number for that.
For just 10 blockchains, you need 50 separate connections.
It's 50.
50, all of which you have to maintain and secure and update. The model gives you very custom per pair security, but it just can't grow past a certain point.
Right. So Axelar saw this and took a totally different approach, the hub and spoke model.
Exactly. They built Axelar as its own layer 1 using the Cosmos SDK to act as that central hub.
And how does that change the math?
It completely flips it. A new chain doesn't have to connect to 50 other chains. It just connects once.
To the Axelar hub.
To the hub. And by doing that, it immediately gets access to every other chain that's already connected. It turns an exponential problem into a simple linear one.
Which is why they've been able to connect over 60 blockchains. That would be, almost impossible with the other model.
Virtually unmanageable, yeah.
Okay, let's get into the nuts and bolts of that hub then. We know it's a decentralized state machine, delegated proof of stake. What's the protocol doing the actual work?
That would be the Cross-Chain Gateway Protocol, or CGP. The best analogy is the Internet's Border Gateway Protocol, BGP.
Hold on, BGP is what routes all the traffic across the entire global internet. You're saying CGP is doing something similar, but for blockchains.
That's the idea. It's the traffic controller and the universal translator that synchronizes the state between all these different chains. It communicates with the outside world through these gateway contracts, smart contracts that live on every connected chain. They're the entry and exit points.
And when a request comes in, it's picked up by relayers, right? But I remember reading that the relayers themselves aren't actually trusted.
That's a critical point. The relayers are there for liveness to make sure the message gets passed along. But the actual security, the trust, comes from Axelar's decentralized validator set.
The DPoS validators.
Right. There are over 75 active validator nodes, and they have to independently check the source chain and agree that the request is legitimate before anything happens.
So that's the foundation. Now, what does this actually let you build? This gets us to general message passing, or GMP.
GMP is the unlock. It means you're not just sending a token from chain A to chain B. You're sending an entire payload.
A payload?
Right.
Meaning?
Data, function calls, anything. You can actually trigger a contract on a destination chain at the same time you move an asset over. It's incredibly powerful.
But if you have 75 plus validators that all need to agree, how is that not incredibly slow and expensive? Consensus at that scale just sounds heavy.
It would be, and that's why they use something called threshold cryptography.
Oh, okay.
So instead of needing 75 individual signatures on the destination chain, which would be a huge, expensive mess, the validators work together to create a single compact signature.
So the destination chain only has to verify one signature, but that one signature cryptographically represents the consensus of the whole group.
Precisely. It keeps transactions small, fast, and cheap. It's a massive efficiency win.
Let's make this real for a second. Our sources use the squid router example. Can you walk us through a swap? Let's say FTM on Phantom to some Axelar USDC on Optimism.
Sure. So you, the user, start the transaction on Phantom. The first thing that happens is your FTM is swapped for Axelar USDC. But at the same time, the system calculates all the future gas fees for relaying, for validating, for the final step on Optimism, and you prepay all of it right there in FTM.
Okay, paying gas once in my native token is a huge improvement. But where's the speed? A full confirmation between those chains should take minutes.
It does. And this is the aha moment. It's a service called GMP Express or Boost.
GMP Express.
If you opt in, an Express relayer sees your transaction start, and it instantly fronts you the tokens on the other side. It gives you a temporary loan of that 0.33 Axelar USDC on Optimism.
Wait, really? So it's basically giving you an advance. The relayer trusts that the decentralized confirmation will eventually happen.
Exactly. You get your funds in 5 to 30 seconds. It feels instant, like Venmo.
While the slow, super secure validation is happening in the background.
Right. And then, once the Axelar validators officially confirm everything, the original funds arrive on Optimism, and they're used to pay back that relayer's loan automatically. You get speed and security layered together.
Okay, that layered security sounds great, but let's dig into that core DPoS model for a second. Delegated proof of stake can have centralization issues, right? Where a few big players dominate everything. How does Axelar stop that?
That's a crucial question. And their main defense is a really unique feature called quadratic voting.
Quadratic voting, explain that.
Well, in a standard DPoS system, your voting power is linear. You double your stake, you double your vote.
Makes sense.
With quadratic voting, your power is proportional to the square root of your stake.
The square root. So what does that mean practically?
It means if you want to double your influence, say, go from having 1 vote to 2 votes, you don't just double your capital, you have to quadruple it.
Wow. So it makes it exponentially more expensive for any single entity to try and take over the network.
Exponentially harder. It's a very clever defense against power concentration, and they add other things on top, like rate limits.
Like a circuit breaker.
Exactly. It caps how much of a major asset like USDC or ETH can be moved in a certain amount of time. It contains the damage if there's ever an exploit.
And what about protecting against a long-term attack, someone trying to compromise validator keys one by one?
That's where key rotations come in. The validators are required to periodically rotate their cryptographic keys. It's just good security hygiene to prevent that kind of slow, persistent attack.
So if you put Axelar's security model up against the competition, where does it land?
It's arguably the most decentralized of the major players. Layer 0 relies on the independence of Oracle and a relayer, plus their verifier networks. Wormhole uses a set of 19 Guardian nodes. They're all valid, but different trust models. Axelar is betting that a true decentralized L1 validator set is the most secure long-term solution.
And the numbers suggest that bet is paying off. The adoption metrics are huge.
They really are. As of mid-2024, they'd processed over $8.6 billion in cross-chain volume and something like 1.85 million transactions across those 64 chains.
Let's shift from the infrastructure to what you can build on top of it. This brings us to the Axelar virtual machine, the AVM. The goal is build once, run everywhere.
Right. Before the AVM, if you were a developer building a multi-chain app, you had to manually deploy and manage and upgrade it on every single chain. It was a nightmare. The AVM turns Axelar itself into a programmable layer. So you can write code that lives on the hub, but it orchestrates actions across all these other connected chains.
And there are a few key products that make this possible, starting with the interchain amplifier.
The amplifier is all about scaling connections. It created a permissionless way for developers to add new chains. Instead of waiting weeks for the core team, developers can now propose and build the integration themselves.
So it speeds things up dramatically.
From weeks to hours. It's key for them getting to chains like Solana, TON, and the XRP ledger.
Okay, next is the interchain maestro. The name sounds like it's an orchestrator.
It is. People have called it the Kubernetes for Web3.
That's a big statement.
It is, but it fits. Imagine you need to upgrade your app's parameters on 5 different L2s instead of 5 separate costly transactions.
Which is a huge pain.
A huge pain. With Maestro, you do one single transaction on the Axelar network, and it pushes that update out to all the connected chains for you simultaneously.
And finally, you have the interchain token service, or ITS. This attacks that liquidity fragmentation problem we mentioned at the start.
Exactly. ITES lets you create interchain tokens that are truly fungible. So a token that moves from Ethereum to Optimism to Avalanche is still recognized as the exact same asset everywhere. No more weird wrapped versions.
This whole stack, it just screams enterprise ready. Which brings us to the big one, institutional adoption.
The biggest proof of concept here was definitely the JP Morgan project, Project Guardian. It was a demo in late 2023. Axelar was used to programmatically rebalance a portfolio of tokenized real-world assets, RWAs, across JP Morgan's private Onyx ledger and the public provenance blockchain.
And what was the big takeaway for a company like JP Morgan?
The efficiency gains were massive. I mean, we're talking about removing thousands of manual steps for portfolio management. It proved that this tech isn't just for DeFi. It solves real expensive problems for big finance.
Okay, we have to talk about the economics, the AXL token, and the huge corporate crossroads this network just went through. Let's start with the tokenomics.
Right, so AXL is the native token. It's used for fees, staking, governance, and the network has a base inflation rate to pay validators, which used to increase with every new chain that was added.
But that changed with the Cobalt upgrade in early 2025?
It did. The upgrade completely changed the incentive model. Now, instead of creating new inflation for new chains, the network uses AXL from the existing supply to reward the verifiers. It decouples growth from inflation.
And they also added a fee burn mechanism, which is huge for token holders.
Exactly. Now, 98% of all the cross-chain gas fees paid in AXL get sent to a burn address. The goal is for network usage to eventually offset the inflation and maybe even make the token deflationary.
Okay, now let's pivot to the news that really shook the community. The Circle acquisition of Interop Labs in December 2025. Interop Labs being the original core development team.
That's right. Circle, the issuer of USDC, bought the Interop Lab team and all their proprietary IP. It was a clear move to accelerate their own internal products.
But, and this is the absolutely critical distinction, they did not acquire the Axelar Network itself.
Correct. The network, the foundation, the AXL token, all of it remained independent and community governed. Circle bought the for-profit company that built the code, not the decentralized network that runs it.
And the market reaction was immediate? The price dropped, what, 15–18%?
It did, because it surfaced this fundamental tension in crypto, the token versus equity problem.
The developers get a massive payday by selling their company equity, while the token holders who actually secured the network for years get no direct benefit from that sale.
Precisely. It raised a lot of tough questions about alignment and value capture for the token.
But the network itself didn't really miss a beat. A new team stepped up right away.
Yep. A group called Common Prefects. They've been longtime contributors, have deep expertise across Cosmos, Solana, Ethereum. They took over stewardship and immediately published a really ambitious 2026 roadmap.
So what does all this mean now? Axelar seems to be doubling down on this bet that a highly decentralized L1 hub architecture is the way to win.
And that new roadmap is all about being ready for institutions. The biggest feature they're working on is something called co-staking. This will let validators stake blue-chip assets like Bitcoin or Ether right alongside their AXL to secure the network.
That is a game changer. They're literally planning to secure the hub using the economic weight of the entire crypto ecosystem.
It just massively increases the cost to attack the network. They're also planning gasless bridging, using idle capital in the gateways to subsidize transaction fees, maybe even making them free for users.
And they're trimming the fat, cutting connections to chains that don't have much activity to focus on the big ecosystems like Solana and Sui.
It's all about focus. So Axelar's big bet is that this combination of decentralized security and linear scalability, now backed by the value of the whole ecosystem, is what will finally unify Web3.
Which leaves you with a really provocative thought to chew on.
If the future of cross-chain security is moving towards this model, securing a network not just with its own native token, but with the massive market caps of external assets like Bitcoin and Ethereum.
What does that imply about how necessary these truly trust-minimized networks are going to become for every single part of finance, both public and private?